a component are going to come in as part of an object, and they're going to be keyed with this name that you give them here. So these things expect an object and will react accordingly. So just put a couple curly braces in there. Let's go ahead and put text in there. And now you'll notice that error went away. React doesn't have a problem with this. And if we go back into Chrome, you'll see exactly the situation I was just describing, right? We just don't see anything. Because now we've at least told React that this component should be getting something called text. But we're not telling it the text needs to be defined. We're simply saying that there might be something here called text. And in this case, it falls back into standard JavaScript mode. It's like, cool. All right, I'm going to take a look at this text variable that the prop has been passed in. It has a value of undefined, so I'm just not going to show anything. And that is exactly the same thing as just not putting anything in here. And there will be times where you actually do this on purpose. You don't necessarily, maybe you might pass an error state, in an error message into the header if something has gone wrong, and you want it to just ignore it if there's no error. But if there is an error, just show a nice big error at the top, right? That's a pretty standard pattern. So this is a normal thing, but again, now you, the developer, have to watch out and make sure that this is supposed to be undefined when it's coming in, essentially. So now down here, we just take text. We put text into the actual tag where we're calling my header. We can put into whatever we want here. In this case, I'm just putting straight string directly. If I go back into Chrome, hello from props. Just come right in. And you'll notice that text is not like a reserved thing or anything. I just made that up. You can call these props whatever you want. Like in this case, the image tag, the built-in HTML image tag, has props that are predefined, you know, alt, class name, source. It's expecting all these things. But your own function, your own component can take whatever it wants, essentially. So, you know, should be deliberate about what you name these things, of course. Now, like I mentioned before, anywhere in our JSX here, we can just put some curly braces in, and that will just evaluate it as JavaScript. So that can happen also inside a prop declaration right here. So rather than taking this text directly, I'm going to take my text variable here that I created, put that in there inside curly braces. And now when I open up the browser, you can see it's coming directly from that component. Now you might notice this is called text, right? This prop is also called text. This can get a little confusing, and you got to be careful here because this is a text that I defined right here within app, whereas this text is the prop I defined within this component. And they're different things, but they can exist kind of in the same plane here for a brief second. So you want to be a little careful when you're naming stuff sometimes to make sure that you can clearly tell what is what, because like I said, these are all your names. You can create whatever you want, essentially. So maybe for clarity here, we'll just call this app text for now. And it's a little clearer what's happening here. Text is defined by this, whereas app text is a specific value from my app that's going into here. Otherwise, exact same behavior. When we go into here, I've passed in the prop successfully. So props are totally immutable once they're inside a component. That means they can't be changed at all. And this is actually a good thing because you generally want that to happen as much as possible in your app. It's always going to be really simple if your components just take in data. They don't know what it is. They don't know what it means. They just kind of display it, and they don't have too much logic around what they do with it. That way you can take all your logic and you try to put it in a very centralized place where it's easy to debug, easy to understand as much as possible, rather than kind of scattering it around your app. That's a choice, of course. You can do whatever you want, but generally props are sort of designed around this idea so that unexpected things don't happen to stuff that goes into a component. If a component is showing something weird, you know that the component itself isn't screwed up, probably. It's coming from outside the component. It helps you track down the problem faster. So if I try in here to change text equals something else, oh, never mind. Okay. So it can be changed. I totally lied because this is JavaScript. And when I passed in that value, it actually passed in a reference to this. not to the, it didn't, I'm actually changing, you know, this might be a little bit too confusing to get into right now. So tell me if this is a little crazy, but if I put app text back in here in the component itself. Oh, interesting. Okay, I totally lied. Okay, well, React Native doesn't let you do this. So if you're in the mobile world, you'll get all sorts of errors when you try doing this. I'm actually really surprised that, that it lets you do that. Okay, so I guess you just got to be really careful. That is not at all what you're supposed to do with props. The whole point of a prop is that it should go in and it should just, it should remain unchanged as much as possible for that exact reason that I just described. But because this is JavaScript and it's just trying to kind of let you do whatever you want to do, you do need to be a little cautious that you don't start messing around with things. So once something comes in as a prop, you should try as much as possible not to change it. If you're going to change the way it's displayed, you can always create a new value out of it and display that instead. But generally, you need to be a little cautious there because in this case, so what just happened there, what I discovered is that app text here is one variable, right? We pass it into my header, it becomes text. I changed text, and now these have totally different values. So if I had gone back and changed app text, it wouldn't necessarily be reflected here. Suddenly you're in potentially very confusing territory. So again, you gotta kind of be careful and do things step by step in a way that makes sense to you, because there aren't always guardrails that are going to prevent weird stuff from happening to your code. But anyway, that was a fun discovery. Yep.
For the does line 5, the word text, does that have to be text in order to pass app text as a prop, or can that be anything?
This can be anything, just as long as it's consistent here, right? All that my header cares about is that it gets an anything prop, right? So now, actually, let's see what happens when we do that, right? So now we're expecting a prop called anything. We're displaying anything, right? We're passing in text instead, right? I didn't change this. So let's say I just changed my code around and like I need to change this to something that's a better name, but I forget to change it here. Now I get nothing. So you notice no errors. It didn't have a problem with that. So not only did it not get the prop it expected, it got a prop that it doesn't know what to do with. And in neither case did it throw an error. So this is where you tend to run into problems because, you know, I made a very simple human error there where I changed it everywhere it was important except for one spot, and now nothing's showing up. And now especially if this is complicated and there's a lot of stuff going on the screen and other things that could be going wrong, I don't know why that's not showing up there. So you kind of have to do some archaeology essentially and figure out like try to trace the exact path through your logic of where the data is going and figure out if it's in fact working or not. So if I change this to anything, and now it just works, right? In this case, this is a very simple little app we're building, and it's easy to tell what's going wrong. But that's the kind of thing you do want to be aware of and watch out for, because yeah, components have no problem taking in props they don't use, and they have no problem with props not being defined. This is actually, I mentioned earlier that React used to have this thing called prop types, and you can still actually pull it in as a third-party package. And what it does is when you create a component, you would essentially do something like this, where you'd be like, my header prop types equals this, and you're saying like, okay, this takes in anything, and that is like a string, right? So, you know, and you could say is required and stuff like that. This is basically what it looked like, and when that was set up, then that exact situation we just did would throw an error because it would say, hey, this is required and it's not there, and it would also say, hey, you didn't specify text as one of your prop types. So it would warn you for that. Right now, like I said, I use TypeScript on most of my apps, and TypeScript would prevent this from happening as well, because TypeScript doesn't just let you pass anything into anything. TypeScript makes you slow down, define exactly what's supposed to be going into this function, and it makes sure that exactly that is going into this function so that none of this happens. So it ends up being more code and more time, but you save yourself weird errors like that.
One of the weird things about TypeScript, though, is it's just a modification for your development environment.
Yes.
Once you get into JavaScript and you're presenting stuff, it would respond the same way that your weird code did.
Yes. Yeah, these are all just tools to save you development time. But yeah, it would not make a site crash or anything like that. React Native is a little different. React Native actually will flat out crash in a lot of cases. Like if I didn't pass anything for anything, the bad word here. Let's call this, I'll just call this prop. If I didn't pass anything into my header as prop in React Native, and then I try to treat prop as though it existed, and I call, some function on it like this. If you do that in a production build of a React Native app, the whole app will crash, which isn't really great either, because it doesn't tell the user anything. It only tells you, the developer, something went wrong if you have some kind of a crash reporting system wired up to your app, which usually you do for this exact reason. So none of this is useful to any of you right now, since we're not doing mobile development, but it's just kind of, it's other ways that this kind of situation can be handled in production. And really neither is ideal, right? Like the whole idea of, like, websites don't typically throw up a ton of errors when things are going wrong. They might be buried in the console. If you actually open up and look at websites you're using and look at their JavaScript console, you might see tons of errors in there, but they try to hide it from the user as much as possible and just pretend everything's okay. Whereas mobile apps don't typically do that as much. They're more happy to just throw up errors or just flat out crash if something has gone wrong. But either way, it's a subpar user experience, because maybe on the web, to your point, like it just takes in this nonsense prop that it's not expecting and tries to run with it. Maybe it's not important enough to the user experience that they just kind of don't notice anything went wrong. Or maybe it totally screws up the way that the app works and the user has no idea what's happening. They're doing everything right. You just made this little mistake. So yeah, the idea is to try to stop you from putting that code into production in the first place, basically. And there's ways you can set up your, usually when we run our environments, when we're actually deploying code, we'll usually run linters and TypeScript checkers on all our stuff first. And if anything like that is wrong, it'll just stop the build and it won't push anything out until it's fixed. But yeah, still on you as the developer to not make that mistake ultimately. So there's only so much the tools can do for you, basically. You do have to be careful not to screw anything up.
Hey, Quinn?
Yeah?
I just wanted to mention, I think if you pass the value as an object, then you can modify it. But if you pass it just as props, it seems like it's read-only. I don't know if that's a distinction you might have been looking for. So like if you just pass props as a parameter and do props.text, then it's read-only. Then you won't be able to modify it, I think.
Yeah, okay, so that's how they do it. All right, so this is another way you can do what I did there is I essentially, by putting the curly braces right there in the function declaration, I'm saying I'm destructuring, that's called destructuring an object in JavaScript. So essentially, props is an object that contains anything I throw in here, in this case, anything, right? So yeah, if I try to say props anything equals new thing, and then I put props.anything into here. So I'm reaching to that object, I'm getting that property, and I'm showing that. Same basic thing. Let's see what that happened. Okay, yes, this is exactly what I was expecting to happen. So thank you for that. That is so funny. I did not know that was an interesting workaround. So there's a couple ways you can deal with this essentially. Like, yeah, if you have a lot of props going into your function, you can just bring in the props object and then do whatever. Let's say we have something else. These are very helpful. This could be a number, this could be some other kind of data, right? And I'm going to take away my broken code here. Okay, so let's say I'm doing a
closing curve brace.
Thank you. All right. Okay, cool. So now I'm passing in multiple props, right? So, and props is just this object that can have just an infinite number of keys that I've defined just by putting stuff into here. That's essentially what it takes in. So one way you can do it is you can just do props dot and then the name of the key and just put that in your code. But that can be a little bit clunky, especially if you have if you're using the same thing multiple times, if you have a lot of this stuff displayed, you start seeing props dot everywhere, it's hard to read. So you can destructure the object like this. Here's one way to do it. And then you can clearly see that these are stuff that I'm pulling out of the props, and then I can just use them as a normal variable. So you can do this setup right here, which it doesn't like. Oh yeah, and then I can take away the props here. So yeah, you do constant in these curly braces and then the names of the keys you're expecting in there, and then equals the thing that you're destructuring. And now you've destructured it. Now anything and something else are now available as just variables within the scope here. So you can use them everywhere and it doesn't clutter up all of your code. If you go back in here, it still works, right? So what I was essentially doing was skipping this entirely and just putting it right here. Like, why do I even need props? I can just say, okay, this object that's coming in, it's got these keys. I just want that. I don't care about props, the object, essentially. But when I did that, I broke that little thing that allowed it to prevent, that was keeping React trying to keep me honest, essentially, and keeping me from messing with the properties of this because it was a read-only object. Now, if I destructure them, I might be able to change them now. Nope. All right, because it's constant. Okay, so maybe this is a better thing to do then. Don't do what I did. Do this instead. If you really want to destructure your props argument, then you can do it right here at the top in this way instead of the way that I did it. And that'll keep things a little bit safer.
Can I ask a quick question?
Yep.
So on that destructuring, will it give you any errors if one of those values ends up as null?
No, and it will be undefined, not null. This is a fun thing about JavaScript, is that there's null, which means it has no value, but that means you've assigned it no value. You have to say this thing equals null for it to equal null, or maybe sometimes maybe you brought in data from somewhere else that had a null in it, but like somewhere that had to be definitively defined. Undefined, on the other hand, also means it has no value, but it means it has never had a value unless you assigned it the value undefined, which you can do. See this, yeah, this is not one of the better aspects of JavaScript, and you can get into more complicated stuff than that. Sometimes zero, the number zero can be treated as like the same thing as undefined, or it's falsy. There's this concept of truthy and falsey in JavaScript, where if you check if something is true or truthy, essentially, then it can declare something false if it's falsy, if it's undefined, if it's null, if it's false, or if it's zero. Those are all falsy values. Yeah. So anyway, but to your question, if that prop didn't get passed in, right? It does on my ESLint plugin is doing this. This is not don't think this is a built-in VS Code thing. This warns me. I don't think React is going to say anything about that. Oops, well, it's going to still annoy about this. Yeah, so I didn't use it, so React doesn't care. Let's say I try to put it here. We just get nothing. So no, it will not throw any errors, because again, undefined is a perfectly valid value for a prop. So is null. if I passed in null, this is no longer an accurate prop name, but whatever. Let's actually pass in the value null. Oops. Then we still get nothing, and there's still no errors. I can also define something as undefined like this if I want. This is exactly the same thing as just not writing this at all. So you might wonder, well, why would I ever do that? The only reason this would ever happen is maybe somewhere else this got, maybe we're pulling in this value from another part of our code, and elsewhere it was undefined, so we were passing in the value undefined. Yeah, all those things are valid. It has no problem with any of that. So yeah, this is where you are. This is where you're gonna have a lot of fun chasing down some weird bugs. It's usually with exactly this kind of scenario where something has become undefined in a situation you didn't expect. It happened in a long chain of logic, and you don't know exactly where it happened, and you're just trying to track down exactly where that change occurs. If indeed that's why it's not showing up, maybe you just screwed up your CSS. Who knows? So now, one thing you can do, of course, is I can take a look using my handy dandy inspector here, which any modern browser will have. Chrome has it, Safari has it, I think Firefox has it. They all have it pretty much. I can take a look here at the actual code. This is a great place to start debugging. If I'm like, hey, there's something that's supposed to be here, it's going to open up the actual code. I'm going to close this. It's going to open up the actual generated HTML from my app. So you will see it looks a lot like what we already had, but you won't see any curly braces and you won't see any JavaScript in here. Instead, you just see exactly what it spits out here. And in this case, I can see clearly that this paragraph does not contain anything there. So if I saw the value here in the markup, but it wasn't showing up on screen, then I know, oh, okay, this is probably a CSS problem. So there's ways you will learn how to kind of track things down. But yeah, it's good to be aware of where you're going to have some little pitfalls like that. Cool. Any other questions? I think now we're about an hour and 15 minutes in. I think this would be a great time for like a quick 5-minute break. If everyone's cool with that, and we come back, we'll start talking about state changes. But any other questions before we break? Cool. All right. I will see everyone back here at 10:20. It's going to give us another couple of minutes for people to kind of go back in. See a lot of faces on our call. Let me, oops, I just stopped sharing. Let me share again. Okay. Great. So we've gone over props, and we've discovered that destructuring them inside the function does funny things. That is such an interesting discovery. Oh yeah, right. Before we get into state, one more thing. So we can pass in, values as props, right? We just passed in a string, we passed in a number. But you can also pass in functions, callback functions. And this is something that gives you a lot more flexibility in terms of just how much these components can do while still having very little knowledge of what's being passed into them. You'll hear a lot about people talking about they want certain parts of their code to be dumb, or just like, I don't know if there's a better word for it, but essentially you don't want it to make assumptions about what it's getting. You just want it to execute on whatever you give it so that you can be pretty confident that if anything is going wrong, that's not where the problem is happening. It's essentially all about, as your app grows, as it gets more complex, trying to identify the points where problems can happen so that you don't have to dig so deep when something does go wrong, because things go wrong all the time. That's being a software developer. So let's try this. We're going to add a button to our header, and we're going to add a prop that shows a simple alert in the parent component in the app itself. So up here in my header, I'm just going to let's get rid of all my goofy names here. I'll keep anything, my wonderfully named prop here. Get rid of all that other stuff. Let's check back into Chrome, make sure I didn't break anything. Cool, this all looks normal. And let's make a button. So we'll do that right underneath our paragraph here. You can just use a built-in HTML button and just say, click me. And that'll just create whatever your browser likes to show as a button. Won't look very pretty, but it's functional. So you should see that show up. You click it, nothing happens. All that gets defined in the on-click prop, essentially, that you're going to pass into the button. So in many ways, button, even though this is a built-in HTML thing, it functions a lot like a React component does, which is one of the great things about JSX is it's kind of built on how HTML already works. And so you can mix in, your native browser functionality with whatever your custom stuff is, and it all looks the same and works the same, and you can have the same expectations. So let's start off here. So normally you would put in, you could just put an on-click handler right in here, right? So we have on-click, and then you open up some curly braces, and now when you click, you're going to execute some JavaScript. So we're going to put an anonymous function, and we're going to use what sometimes referred to as the fat arrow syntax to do it, where you have a open parenthesis in this case, because we don't care about what's being passed in, and then we have an equal sign and is it a caret, technically, an arrow? I don't know what it is. But this is called the fat arrow sometimes. This is something you will see a lot in modern JavaScript, and essentially it is it's just the same thing really as creating a function like this in just like a little bit less code. So you can easily throw it into little things like this. And then within here, we can use alert. That's just a built-in browser thing. We're going to say button was clicked. Okay, so once that's all set up and I click the button now, I get an alert. Just basic browser alert, no styling or anything, but it works. Great. So what we want to do now is, let's say for some reason this alert is to be something a little more complicated. It needs access to some kind of data that we're not passing into this component, or for any number of reasons, you might not want the component to know exactly what it's doing. Maybe you're going to change out how you do your alerts and use some kind of custom solution or something. So rather than having the my header be responsible for knowing to bring up a system alert when this button is clicked, we just want it to know, hey, when this button gets clicked, use the button click handler that we gave you, and just call that function and just do it. Don't worry about what it means. So what we can do here is we can pass this in. I'm going to get rid of something else here since we're not using it anymore. And let's call this on button clicked. You'll often see this kind of naming convention, on button clicked. And we're going to put basically the same thing in here, right? And we're going to get rid of that. So now let's say our props, in addition to taking in this anything prop, we also are going to have our on button clicked prop, which is helpfully auto-filled for me by my code editor. And in here, should be able to just put that in right like that. And you notice this time I didn't do the function syntax. I just passed the function directly into here. And hopefully that'll work. Yep, cool. Nothing has changed here. This is coming from I am parent component logic. Just to make sure clearly that all of that logic lives in here. Great. And that follows exactly what I said here. So just like anything else, like we're just passing in JavaScript of some kind to our component. It doesn't know what this is. It knows that, in fact, it really doesn't know what this is, because my header doesn't even know this is a function, really. It just knows this is something, and it passes it directly onto button to its on-click handler. It just hands it over. So and ultimately, it is button that's calling this function, not even the logic I did. You could also do it this way, and depending on, in this case, onClick is just expecting a plain old function that doesn't do anything. It doesn't take in any parameters or anything like that. So I can get away with this, but sometimes you need to be a little more explicit and like call it directly. So we could also do this. If the onClick handler passed something back, and I think it actually does because it's a built-in browser handler that I think gives you back some information about the click. I'm pretty sure. I'm actually not 100%. We could also potentially take some data back in and pass that into our click handler, and that way we have a two-way communication path going. That's a little hard to explain without showing an example, but we might get into that a little later. So this should do the exact same thing essentially. Now, this is where you got to be careful. So what if I forgot to add this right here? Because a lot of the time you will. This is a very, very common mistake no matter how experienced you get. And I just do this. So it looks a lot like I'm calling on button clicked, right? Like I'm just calling that function when I click, right? But when I go back to the screen, you'll notice I didn't click anything and this popped up anyway. In fact, it keeps popping up. If I refresh the screen, it pops up again. That's a little weird. And now when I click on this, nothing happens. So what's going on there? Once again, we're getting into sort of the no errors JavaScript zone where nothing has explicitly told us something has gone wrong, but this is not behaving the way we're expecting it to. So
you invoked the function instead of just passing the function.
Exactly. So what happened was, so the reason that just popped up as soon as the page was reloaded is because anything that's inside these curly braces just gets executed right then and there, no matter where in your markup it is. So it went, okay, on button clicked, and it just fired that logic right away. So that just popped up. Then it took the return value of that click function and passed that into onClick, which is why it didn't do anything. Because basically everything in JavaScript has some kind of return value, even if that return value is undefined. And in this case, because we don't actually return anything from this alert, it got undefined, and it decided that, the onClick handler was just taking an undefined as its value, which is totally valid. A button doesn't have to have a click handler. It won't give you any errors. It just simply won't do anything. And so that was exactly what happened. So this is a really easy mistake to make. And like I said, you will keep doing it even when you're years down the road. So it's a good thing to remember that when things start acting weird, that kind of thing can happen. So, so let's go ahead and fix that and go back to this. All right, now we're getting the behavior that we're expecting. So that's just another example of, probably you're not going to do much more complicated stuff than that. I think that passing in a callback function is about as complex as you ever really want your components to get, but it just goes to show that this can be way more than just passing in information. This is also passing in interactivity, and it might even be taking back some of the stuff from the component itself. Like for example, remember how anything I define in here, right, is only exists within my header's scope. So app might be passing props down into my header, but app doesn't get any of the props that, or any of the variables that exist within my header for free. Essentially, they are invisible to app. So if I create, you know, my header thing equals, you know, whatever, this could be any number of things. Maybe there's a text field in here and you're entering in some text or something like that. But the point is, like, this value exists here, does not exist in here. However, I can have that callback function that I pass in take in a value from the child when it gets called. Right here. So now what I can do is, inside this onClick handler, I can call on button click, but I can pass in my header thing, a thing only my header knows about. But this knows about it too, because it's in the same block. And now when I go back here, cool, and it got the value too. So callback functions are often used for exactly this reason. If you want to just pass back a little bit of something that exists only in some subcomponent or subcomponent, this is one way to do that. And it allows that kind of two-way communication between your parent and your child components, but it is something that you can moderate really well. It's actually usually really handy that you don't have full access to all of the variables that exist in the children at all times, because the whole point is those children should be handling that on their own. It shouldn't be something the parent is worried about unless it's this kind of situation. Does that make sense to everybody? That was an ad lib, so I don't usually do that. I'm curious if it's confusing at all, but that's a pretty good example of why you would actually use this in the real world. Cool. So, oops, I just went backwards. Now, we talked about props. Props are a huge part of React and probably what you're going to use the most, but you're also sometimes, remember I mentioned maybe you have a text field or something and the user enters it in. You have some kind of dynamic data that you don't simply pass down from some top level place. You also want to be getting stuff back from the user, or maybe it's coming from API calls or whatever, stuff that's coming in and needs to be mutable. The way you handle that is through state. So every component has props. Those got passed in from outside, and except in the weird example I managed to find today, shouldn't generally be changed. They're supposed to just be things that the component uses. State are internal values that the component manages itself, and that do change. They're expected to change. So there's all this stuff designed around the ways that you would change those variables. And this is where there's two basic ways to do it, and it diverges fairly strongly, I would say, from the old class-based syntax, which is the way you used to do it. It used to be basically when they first introduced functional components, you probably used those most of the time unless you needed state. If you needed state, you turned your functional component into a class component, and then you gave, that comes with a built-in state, and you can change that state at will, although you have to do it in specific ways. However, in the last couple of years, they added something called hooks. Hooks actually are a pretty broad range of functionality within React, but most of the time when you're using them, you use them in this way. There's a use state hook, essentially, and that can be used only in functional components. It actually doesn't work in class-based components at all. So I'll show you the classic way to do it really quick. We're going to update the state on the button press. So essentially, rather than calling back to the parent, we just want to change something in the state of the header itself. So we're going to go ahead and I'm going to get rid of this on button clicked. Actually, you know what? We already have that connection. Let's keep it. Let's keep it for now. I'm going to get rid of this part, though. I'm just going to take away the value we're passing back. And now we are simply calling on button clicked. Actually, if I don't change this at all, you'll see that this will still work. It won't throw any errors. It will just simply get an input of undefined. Yep. And you notice here, it actually says the word undefined. It doesn't just say blank. Whereas before, remember, we had undefined values and they just weren't showing up in our markup. So sometimes you'll get this and sometimes you'll get the other depending on the circumstance. In this case, the alert is trying to give me a little bit more information than like my on-page markup, essentially, which just treats undefined as just blank space. So another little bit of JavaScript unpredictability that you might have to deal with. So let's go back and rather than do this alert, we're just going to take this alert out entirely, right? So we've got this function here. Okay. So now our function does nothing, but I want to take this, and now when that button gets clicked, I want to change something in the state here. So the old way to do this is now my functional component app needs to turn into a class in order to be able to handle this. So I'm going to get rid of this whole first line here. Let's say class app, and then that is going to extends React.component. React component being a class that exists within React. And so when we extend it, we're going to be inheriting all of its like lifecycle methods and all these different things that it can do as a component. And technically under the hood, I think we're sort of doing this already just by declaring this function. It's just that React is kind of abstracting all that for us. So we don't have to worry about it. And it's just giving us basic functionality. So now my editor no longer likes all this stuff. All this stuff here, all the markup that we're returning, the component still needs to return that somehow. It needs to show itself. But the way it does that is in a render method right here. And this render method functions basically exactly the same way. I have the right number of, okay. I guess that's okay. No, it's not. Normally, this should be auto indenting in my code editor and it's not doing it, but that's fine. It still works. So now that we have a class and we have a single render method, we actually basically just recreated what we already had. That's all a functional component is it's like a class with just a render method. And classes, on the other hand, need to implement a render method in order to work. They have to return something again, even if it's null. But that's all they really need to be proper classes. So now if I go back in here, everything's behaving the same way. This clicking is no longer doing anything because I'm not passing any logic in, but everything's displaying, no errors. So we're good. But now that we have a class component here, we get access to state. And there's a few ways that you can set the state. And let's see if I remember this. I think you can just do it at the top here, if I'm remembering correctly. It's not yelling at me. Okay. Sometimes you will see like a constructor method here, and that's where they'll create the state. Sometimes they just do it at the top here, but essentially a class component has this built-in concept of state, and state, just like props, is just an object with custom keys and custom values that you define. But unlike props, they're designed to be changed. However, they are designed to be changed in a very specific way through this call Setstate. You're not supposed to just reach in and change it, even though you can. So before we change anything, let's take out this page content here, and I'm just going to replace this with I am from state. I'm going to grab this.state.change me. Okay, that didn't refresh for some reason. Okay, cool. So much like a prop, I can just drop it right into the JSX and it will just display it, right? And it has this value, nothing, the string nothing, because that's what I set it to in the beginning. Let me call it initial value so it's a little clearer what I'm doing. I'm not trying to there we go. So typically when you set up your state, you'll give it some sort of initial value that might be undefined, or it might be like a blank string or something. It can be whatever you want, but it should have something to begin with. Now, what we can do is before the render even happens, if I want to change that value, I call this.setState. And this.setState is a specific component function that handles state changes in an organized way. So what you do is you pass into state an object, and this object contains all the changes you want to make to the state, basically. It will only change the things that you specify here. So if I change me, and I put that to changed value essentially, right? So I'm giving it a little piece of state, and I'm saying this is the change I want you to make, go ahead and do that. And now I go back in here and it breaks, right? Because I didn't do this so what I just did there is setting the state triggers another render because I've changed the data, right? That's the diffing algorithm that we talked about way back when. That calls this render function again, which then changes the state here again and loops infinitely. And fortunately, rather than just my browser crashing entirely, there's a little bit of a stopgap in here that makes sure that that doesn't actually, the maximum update depth is exceeded, and then it will stop and yell at me rather than just bringing my browser to a dead halt. So I don't want to put this directly into the render. I want to do this somewhere that only gets called once or only gets called in specific circumstances. So one place I can do that is I can do it in component did mount. I mentioned there's lifecycle methods. This is what I'm talking about. The whole idea of the class-based syntax and how React was originally designed was you sort of have a component and then it kind of goes through these different steps in its life cycle from when you first create it to when it mounts, meaning that it's been rendered and it's like on screen and available, to every time it just rendered, every time it just got new props, when the component is unmounting, when it's being removed from the view for some reason, although it doesn't happen super often, things like that. And it allowed you to put your logic at these very specific places along that cycle. But you don't really see that as much anymore because most of the times these weren't super useful, and I think they could cause some weird side effects at some point. I'm not 100% sure why they moved away from it, but they were not things you used a ton of. Usually render was where most of your action was happening. So if I change it to component did mount, so I'm only going to call this once. The component has been brought on, basically like component did mount means that this parent that's rendering it right here just rendered it successfully and now it exists. It's here and ready to roll. So I can put in a change in state there. And this is going to trigger a re-render, and then we get the change value and nothing breaks. So, so that change of state can happen anytime I want. So if we want, we can have it happen when you click the button. So let's do that. So rather than just happening once, actually I'll keep this here. So we can see now, hopefully, the difference between the original value, which we don't even get a chance to see, this changed value, let's say on mount value. And now here we have this empty on button clicked handler that is now currently doing nothing, but we can put whatever logic in here we want. So what I can do is call Setstate from inside. Yep.
Sorry to interrupt. Is there any way you could increase your font size a little bit?
Yep.
Sorry about that.
Better? Is that better?
Yep, thank you.
Cool. Yeah, no problem. So yeah, so now what we're going to do is we're going to call this.setState, and we will do change me to button clicked value. Great. And now let's see what happens. So let's open up the browser. So we've got the on mount value. That's the same behavior we saw before. Now I click, boom, button clicked value. So I passed, this is a great example of, we've already created a surprising amount of complexity in just these two components, right? We have this parent that has state. The parent also passes in a handler to its child. The child calls the handler, which then goes back up here and then changes the state in the parent. And this is usually how you want things to work. You generally want the state to live at a pretty high level and not at a low level. The low level components, the sort of ones that have the least amount of logic, just take in props, and that can change based on the state. For example, rather than showing the state here, I'm just going to pull this out. Let's call this I'm the parent, right? Here, this anything value, for example, rather than being this one constant we put here, let's change that so that this is now this dot state dot change me. And we'll go back here. Okay, there's I'm a value, button clicked value. So now we have a little bit of a flow going here, essentially, right? We pass in this state value. We also pass in the function, which changes the state value. However, my header doesn't have any idea what the relationship between these things are. It doesn't know what state is. All it knows is it's getting a single text value and it's getting a single function. It calls the function when you press the button, it shows the value here. It doesn't know what's happening elsewhere. This could be some really convoluted logic in here, but we're keeping all that logic in one place. All of the changes happen right here. Nothing here ever changes. It simply does what it's told. And this is where you know if things are getting weird, not behaving the way you want. There's a very good chance that the problem is here, not in the child component, especially if it's otherwise behaving the way that you expect. Is it making sense so far? Cool. Now, I mentioned that you have to call this dot set state, right? What if we didn't? Let's see what happens if React, let's say we just want to change this dot state dot change me to a new value. All right. Now you notice no errors here. My editor has no problem. Let's see if the browser has an issue. Browser says nothing. So let's go ahead and click this and see what happens. Nothing happens. Let's click it again. Nothing. Now, you can't see it, but what's actually going on, and you'll be clearer if there was something else on here that triggered a re-render, you would actually see the value did change. The problem is, since I didn't call set state, nothing told React to update, essentially. So this is where the diffing algorithm is not total magic, right? It doesn't always respond to every single change. Set state is specifically designed to change the state, then call a re-render once the change has occurred, and it's asynchronous. So there's a very, very slight delay. It's on the order of milliseconds. It's tiny, but it's there. It's enough of a delay that if other things change on screen, that it might not, unless you're doing things in the right order, things might not actually quite get up to date. And then you have things that are out of sync. They're not displaying the way you're expecting to, and things get really wonky. And then you're back in the pre-React days of trying to troubleshoot why your view isn't updating. So it's very important that you stick to the pattern here and do this correctly, because it doesn't stop you from doing this. Like we're very solidly in the JavaScript land of, I'm just going to let you do what you're doing, and I hope you know what you're doing, essentially. So go back to the previous way, and now we're back to the proper functionality. So that is the classic way. Now, if we're going to use hooks, it's actually going to be very, very similar, but it's a little bit less code. And it kind of, hooks are based around the idea that rather than managing this one bit of state, before I get into this, let me show you one thing that's important. So the idea also with classic state is like you have this one blob of state, you have this big object. This could be quite large if you have a complicated component, right? So let's say there's some other stuff in here, and that just has some value. Now, let's go ahead and display that other stuff value on screen so you can see what it is. Okay. Oops, sorry. This dot state dot other stuff. Oh, you also notice that this is a thing we didn't have in the functional component. So that keyword is really important in JavaScript, and it refers to your current context, essentially. And it's something you have to do in a class for different parts of the class to talk to other parts of the class. You don't have to do it in a function component because everything within a function is defined within that scope, and it's all available right there, and it's just very simple. But a class is a little weird because each of these methods has its own scope. So if I created something in here, right? And we'll put it down here. Okay, so I'm displaying this, right? I've created this here. Okay, but let's say I want to try to grab that whatever constant that I created and set it to the state up here. So instead of on mount value, this is going to be whatever. Well, right away I get an error right here. This isn't defined. And this will also actually cause a React error. Whatever only exists inside render, inside these curly braces. It's not available anywhere else. However, if I say this dot whatever, this isn't going to work because I'm doing it in the wrong order. Now it becomes part of the entire class's context. It's part of that whole scope. So essentially, it's available now in any of these different methods. And that's exactly the same with state, and it's the same with props too. If I passed in props to here, I would have to do this dot props rather than just props, essentially. So that's kind of key. But anyway, so let's say I'm displaying this other stuff here, right? And other stuff is equal to 200. Now you'll notice that we changed the value, right, of the state by setting the state inside that componented mount right here. But the nice thing is we only changed what we passed in. So even though there's other stuff in the state, we didn't just like overwrite the entire state so that other stuff no longer exists, nor do we change its value in any way. The set state knows that whatever you're passing in are your changes and nothing else. And everything else will just remain the same in the state. So that's an important thing to keep in mind. But that's the basic kind of concept of state in a class component, is that it is this one big object and you're managing this one big object through very specific interactions. The concept behind hooks is that you are sort of handling each piece of your state individually. So in this case, you wouldn't have a single object. I mean, you could technically do this, but you generally would not have a single object that contains multiple properties and those change over time. You would make these two separate hooks and you would change them in different ways, essentially. Like you just have one variable at a time. So I'm going to show you how that works. So let's go back to our function, make this a function again. I'm just going to remove this entirely, get rid of render as well. So now we're back to where we started. This is all going to be broken because we no longer have a state. Yep, all sorts of problems, right? This dot state doesn't exist. None of this exists. So let's get rid of this dot state. And let's just create some variables called change me and other stuff. So these are state variables. We want these to change somehow, but we're going to use hooks instead. And the way we do that is up here where we're importing React, we also have to import a helper function that it gives us called useState. And that's going to be inside curly braces. That's important. I don't know if you've gotten into how imports work, but basically, see how we're exporting default app down here? That means that over here in index where we import the app, we just import it with no curly braces. Exporting the default means like just the one thing from this file that's the most important, here it is. Whereas if we just said export app like this, then we would have to get app inside curly braces. So usually you do that when a file is going to have a bunch of exports as opposed to a single one. Although in React's case, it has both. It is both exporting all of React, but it's also exporting some separate stuff individually. So you'll see this a little bit, but that's all that means, just so you know. All right, so now we got useState. This is the useState hook. useState allows us to create little bitty pieces of state on the fly. So when we create change me, I'm going to comment this out for now, so we just worry about one at a time. So when we create change me, here's how we do it. We are going to create a array that's change me and then set change me. We're going to create the variable and then the function that sets its value inside an array, and then assign that to the result of useState. So this might look a little confusing, right? What's actually happening here is we're essentially saying like useState is giving us back an array, basically. It's just giving us an array, and that array contains like a possible stateful value and a function. And then we could say stuff like change me equals array thing 0 and set change me equals array thing 1. So essentially, like, we're doing the same thing we did in the destructuring argument here, but the way you're destructuring an array. So we're saying, okay, this thing's gonna give me back an array with two elements, and I want the first element to be called change me and the second one to be called set change me, and that's all I'm doing. So a little bit of a weird syntax, but that's all that's actually happening under the hood. Cool. So now we've done that. We've got change me getting passed into our header. Let's go back into the browser and see what's going on. Doesn't like that. All right, because okay. All right, so now no errors, but we're not getting anything up here, right? Change me has no value because we just use state. If you don't put anything into this call here, we'll just give you back undefined as the initial value of change me. So you can set initial value here, and if you want, you can pass in whatever you want, and it will just give you back change me set to that value initially. So we can say initial value in here. Boom. So now we've actually got something when we're passing it back into our header. Now, set change me is now a function that we can call whenever we want. So much like we called set state before, I'm going to call this right here inside my function, and I'm going to call it to new value. And I did the exact same thing as last time. All right, so how do I keep this from happening, right? So once again, it's essentially like what I did last time, where I change it, it re-renders, and it just keeps re-rendering infinitely. You'll notice that's a slightly different error this time, and it's actually a little more helpful this time, but exact same problem. So the way we get around this is through a different hook called useEffect. And useEffect is designed basically to replace those lifecycle methods that I just talked about. So previously, you had these lifecycle methods that fired at certain times when your component got props, when it had just re-rendered or things like that. And essentially, a functional component only ever really renders. It doesn't do, I mean, it is technically doing all that other stuff, but useEffect is designed to be the new way to handle these kind of situations where you only want something to happen once or only when certain things change. So what you do is you just do useEffect. And useEffect is a function that takes in your function, your anonymous function, just the same way we did here when we passed in the button click handler, right? It takes in whatever you want to do and kind of seals it off from the render logic so that it doesn't happen every single time things render. Although actually, the way I've written it right here, it will still happen every single time. Oh, no, it won't. Look at that. Okay, I thought you had to pass in an empty dependency array. Okay, so you got a little bit of safety now. It's not just going to endlessly loop. You can also pass an array at the end of it. This is called a dependency array. This is where things start getting a little complicated, unfortunately. It's like a lot of complicated stuff very quickly. But
so when you don't pass in a dependency array, it's the thing inside that has changed that will cause the useEffect to trigger.
Okay. Well, there we go. Yeah, you can specify what you want, when you want this to fire by passing in certain things. So if I had other stuff, which doesn't exist yet, but it will shortly, and I only want, whenever other stuff changes, I want this to run again, then that will happen, basically. If you don't pass in anything, then yeah, I believe it just does it once when it first renders.
Are you still using line 25 with this set state, or 27? Sorry.
Nope, that'll do nothing now because this set state is undefined. So, yep.
Okay, just make sure. Thank you.
Yes. Yeah. So what we actually want to do is set change me to changed by button click. All right, same basic concept. We're calling this, and it doesn't work. Hang on. Okay. So the useEffect is actually running every time. So, well, it's running again because, as we just pointed out, when change me changes, this is going to run essentially. So if we only want this to happen on the first render, I believe we pass in an empty array here. There we go. Now it works. Okay. So essentially, you can have something. Use effect allows you to change things every time things render, but also protect you against that infinite render loop, or only when certain things change that may or may not be related to that. Or in this case, when I pass in an empty array here, it will only run it once. So it's the same thing basically as doing that component will mount thing that I did earlier. It's like the first time this renders, run this. After that, no matter what changes, don't run it again, essentially. Unfortunately, like this is a lot more confusing, I think, than this is powerful, but it's less intuitive in many ways than the class-based syntax, where it was pretty clear, like this is happening right here, right exactly when this component's in this particular state. Whereas here, you kind of just have to know how use effect hooks work. And they're fairly new to me too. I was struggling just a bit a few weeks ago on a project with exactly this problem, although it turned out it wasn't use effect that was breaking. I just thought I didn't understand it. It was actually a different problem. But the whole point of these are designed to remove the need for those dependency those lifecycle methods from the class syntax. Otherwise, everything basically behaves the same way. It's still the concept of like you have these stateful variables that can change, and that will always trigger re-render, and you're dealing with the changes it makes to your component as that happens, essentially. So, yep.
Sorry, could you go over this a little bit more in detail? So is line 21 doing anything right now?
Yes. So what happens now is basically, so the app function fires, right, for the first time. It has never rendered before. These get created with the initial value. They are only set to that initial value for now. They're expected to change at some point. Even when the app re-renders, this is not going to like fire again. So that's partly what's confusing, right? It kind of looks like, oh, every single time this renders, we're going to be setting to the initial value, right? Well, no, you're not, because that's not how useState works. useState knows that this app has rendered before, and it's not going to get the initial value again. It only does it the first time it renders. So now that's happened, right? So we have change me as a value of initial state, and we have a function set change me. So it moves on to the use effect block. Since this is the first time it's rendered, it's just going to go ahead and do the logic that's in here. So it calls set change me. This changes to new value. That triggers a re-render. Although, you know what? I lied a little bit. So this actually, the thing about use effect is they will always run after the initial render. So in fact, what actually happens is it skips this. It says, okay, cool, I'll come back to here once I've rendered all the stuff below this. So it goes over it. It shows our header. You know, it passes in the change me value as this anything value, right? So it's displaying that in the header, displays its own stuff, finishes off, it's done. Okay, cool. Now it goes back to use effect, having rendered that once. It changes the value of change me to new value. Since that changed, it re-renders everything. So now we start over from scratch. If we had multiple use effect blocks, it would do all of them first before it triggered the re-render, but they always fire after render. That's the idea. So it comes back here. It sees that this is a use state block, so it basically doesn't do anything. This has already been covered. The value exists. It doesn't reset it to the initial value. Skips over use effect again, and it re-renders everything. And then it gets back to use effect. It sees the empty array, and it knows, okay, this has no dependencies. Like this is essentially a one-time firing block, and it does nothing. And it will do that every single time it renders. It will never call this again, except for that first time it rendered.
Gotcha. Okay, so hypothetically, on line 22, if you included change me as a dependency, we'd get into an infinite loop. Would that be correct? Because we're changing the value.
It shouldn't loop infinitely, because it's smart enough to know that when you like, yes, I update when this changes, but since I'm changing it within it, don't then update it again. Like don't get into an infinite loop. Although okay. Let's see if I'm right about that. It's a new value. Yeah, essentially. Okay, so it does not get into an infinite loop, but you see it overwrites the logic that we've created.
Okay, and I know there's some concept. I don't know if you can go over this, so apologies for jumping ahead. But there's some concept of if you do have a dependency item, you want to check if it's changed. Is that correct? Like you want to check the previous value versus the new value, or do you not need to do that?
No, you don't need to do that because it won't fire otherwise. So Like for example, hang on a second. Okay, no, it does this anyway. I'm just trying to figure out how to set up what you're describing. But essentially, all right, let's try this. Let's
I guess I think my apology. I think it's the case of if you have multiple dependencies, you need to check which one changed, right?
Oh, I see what you mean. Yeah, you would not
Sorry.
know. Yes. So we could also put, so we haven't done other stuff yet, right? Other stuff doesn't exist in like that's like a whole separate thing we're going to create. We're going to do it the exact same way, right? Create other stuff, set other stuff. And we'll use state and we'll just have other stuff be a number, right? So it starts at 0. Okay. So we can also put other stuff in here as part of the dependency array. Now, if either change me or other stuff updates, this will fire. So if we have a second button, right, that only changes, let's create a new button. I'm going to make a click handler. I'm just doing it right here inside the app component, so we're not confused about where the logic lives. And we'll have this set other stuff to 100. So now when we click this, that's going to change this value. Well, you're not going to be able to tell anything changed here because it's right. So since this is already being set to new value.
Yeah, you could just put other value in there, like a back ticket, and then include other value in this new value.
Or could you just click
Oh.
the
I see what you mean. Yeah, got it. Good point. Yeah, we'll put it right in here so we can see that this has in fact fired. Yeah, there we go. So yeah, but the thing is, change me didn't change, although it changes within this. But again, useEffect is smart enough not to create an infinite loop when that happens. But yeah, but you don't know. Yes, you yourself, the developer, don't know which one of these updated. So you might want one set of behavior when other stuff changes, and you might want one set of behavior when change me changes. So in that case, yes, you would need to check to see if it had changed or not. Now, of course, it is run after the render.
And
So-
typically those would be just put into 2 separate useEffects if you needed separate logic for each of them.
Yeah, generally that for that exact reason, you don't really want to do it this way, because I'm not actually certain how you would get the previous value. I think useEffect might take a parameter in here that gives you the previous values, but I'm not sure. Because yeah, again, typically you don't want to do that. The whole point is to do multiple useEffect blocks for each effect and make that like a separate effect. That's kind of like I said, the whole idea here is like you're no longer thinking of your one state that's changing. You're thinking of like this particular value changed, and on this particular value change, I want to do this particular thing. So it ends up being a lot more code sometimes, but at the very least, it is distinct. Hopefully, what's changing when and why, and what kind of an effect you want from that.
Gotcha. All right, that makes more sense. Thanks so much.
Sure. Anyone have any other questions?
Is useEffect overriding line 28?
No. useEffect. Oh well, yes, it is. I mean,
Okay.
they're both happening. So it's not like this still fires. This does get changed. Like I could just throw up an alert instead, just so that something else happens. Oops. Okay, yeah. So there's an example, right?
Okay.
Both are firing, both are happening. In this case, though, since I'm immediately changing the value to something else, it happens so fast you don't see the other value at any point before it renders again. So.
And you can also do just like if statements to say if this is the first trip through, do initialization stuff. Otherwise, do your repeated click action.
If I were going to do that, I would probably have a single useEffect that has this. So I know this only happens once, and then do a separate useEffect for every time that value changes otherwise.
The other one is always going to fire though after the function, after the entire JavaScript already loads. So because you're forcing it, the use effect with the dependency will always fire at the end of the complete full render. I'm sorry, the complete full render. You would still need that initialization skip. Don't do this the first time.
Oh, I think I see what you're saying. So like if I want like to
Just
okay,
like you saw the alert happen, you don't want it to technically alert that first time. So you would need to put an if around that alert. And so that's why sometimes you'll have that dependency, and then you'll have your initialization effect on one half of the if and the repeated effect on the second half of the if.
I think I see what you're saying. Like, yeah, let's see if we can set up an example for that. So
the alert was really good.
Yeah, the alert was good. So rather than changing the value. So what you're saying here is we don't want the alert to fire until it changes, right? But we also don't want this to happen on the initial. This should only happen after button click. Yeah, I see what you're saying. Okay, yeah, so you would need some extra logic in there because it will fire anyway that first time, even though, because this is.
Because it's going from undefined to something.
Mm-hmm.
So therefore change me has changed.
Yeah, I'm sure there's a way to deal with this. I'm not 100% sure what it is. But yeah, you would want to either run some kind of manual check. Of course, you have to set a variable saying like this is run before. So I'm pretty sure.
The way I typically do it is I don't set the initial value in the use state. And then I set it in the use effect. So I know that if undefined, it's the first trip through. I set the value, and then the next trip through, it becomes whatever it is.
Yeah, that's definitely one way to do it. Good thoughts. Cool. Any other questions? All right, so that essentially, there's the questions. Okay. This is where I'm gonna have you all do your own independent project really quick. But before we get into this, I just want to point out that like this right here, essentially, you've now covered most of the basics of React. Like this is actually kind of all there is to React proper. There's, it gets more complex as you bring in other frameworks. Things like Redux can make it, vastly more complex, like I said, but also much more powerful and much easier to manage a larger application. But essentially, as far as specifically React logic, you're not really going to get into a lot more than basically this. The basic concept of state and props, of splitting up your logic into separate components and figuring out how those components talk to each other is the vast majority of the React proper code that you're ever going to do. And all the complexity now comes from what you need your app to do, basically, like how many different parts you have, how they need to talk to each other, what they need to be conveying to each other, and that sort of thing is where most of the complexity comes from. So like I said, this is just the view layer, and it's designed to be fairly simple. It's designed to integrate really well into HTML as you know it. And the new hooks thing is designed to make it a little bit easier to manage state in kind of discrete ways. Although of course it causes its own set of complexities that we've just seen just in this little conversation right here, right? We've got a surprising amount of complexity out of what is really just a few things changing on very small interactions. So all this stuff can get very complicated, but the underpinnings are pretty simple. There's not a lot more to it than that. So once you can generally get an idea of how your data is flowing through your app, when you should be using state, how to use the use effect hooks, because they are their own beast, and how you should be passing props down, then you're well on your way to like writing legit React code, and you can do a lot with what we've already learned. So with that said, I'd like you all to I know this looks a horrible yellow because in my initial run at this tutorial, I also changed the background color to yellow for some reason. So fortunately, we didn't do that this time, but you can do it if you want. Yeah, I want you all to do a little independent project, and we're going to create a click counter. So rather than just a value that changes once, I want to see how you deal with a value that changes over time and maintains that. And you can do this any way you want, just as long as the counter exists in state somehow, and the update happens through a button press. And then once we're finished, I'll show you how I did it, and we can answer any questions that you have. So I'll start off giving everyone about 15 minutes for that. We're actually kind of blowing through our time today, man. This is much faster. It seems to be going much faster than it usually does for some reason. So I'll just make sure that we have till noon, right? Officially?
Yep.
I think so.
Yep.
Okay.
If you don't mind, maybe we could take a quick break and then get into the coding.
Yeah, why don't we take a break, take a 5-ish minute break, and then come back, and then we'll do another 15 minutes after that, which will get us up to 11:45, and then hopefully that should be enough time to go through the solution and answer any questions anyone has. Sound good? Great. All right.
Yeah, I think it'd be helpful to keep that slide open, just to give a target or just some visual
Okay.
what we kind of want to see.
Cool. Everyone see that?
All right, so are we working on this challenge right now?
Yes.
Okay.
Yeah, let's take about 15 minutes. Normally I like to keep a little longer if they need it, but since we're running low on time, I just want to make sure there's time for any questions at the end if people still have some. So like I said, I can send out a link to the GitHub repo that has the code if people want to take a look at it later. It won't be exactly what I did here because it's from an earlier workshop, but it's pretty close. So, and incidentally, if people want to like Slack me, send me an email or whatever, I'm pretty available. Feel free to ask questions or reach out.
Hey, Quinn, do you mind if I ask you a question?
Yes.
This is unrelated to this particular challenge, but just a common maybe example on a web page where, let's say you have a user input field where they type in text, and then you have a button that wants to use that value. Mm-hmm. So I'm looking on the web right now, and it seems like the default response for that to handle that for React is to have an on-change handler for your input text field. And then if you click the button, then it can use that value because the value is already correct. My question, again, if you happen to have a good insight, is that inefficient? As in, what if I hypothetically only want to use that text value once I click the button? As in, I don't want to update it each time the user is like typing in 5 letters at a time or whatever it might be. Is there any inefficiency that should be considered? And if so, is there a way to kind of only handle or only get the input value when I click the button instead of having the input value being constantly updated through the on-change handler?
You do. I have not found it causing performance problems. It's pretty, and you can debounce too, so it's not doing it so there's a slight delay after you type if you want. The way you're describing where you just get the value after when you click the button is kind of the old school way to do it. You would probably use something like jQuery and click the button and populate all the values by kind of scraping through all your elements and getting the value and then sending that along. But that just isn't really as much how React works, since it's less about the old way was kind of your HTML sort of existed separate from the JavaScript, and the JavaScript was kind of trying its best to read your page and figure out what's going on and make changes where it could. Whereas JavaScript is much more running the show in React. So the idea really is that, yeah, you probably would use an on-change handler and just update that value as it changes. And even honestly, if you're doing that in a real app, you'd probably just be using a third-party library like Formic anyway. So you wouldn't even have to deal with that because forms are complicated. They are always a huge pain. There's so many different states you have to deal with. You have to do validation on the data people are putting in. You have to show error messages in a helpful way. You have to make those error messages go away when a person starts typing again, so it's not constantly yelling at them. So that's why you usually use something like Formic or another library along those lines, because they've already solved a lot of those problems. But yeah, if we had more time, I probably would show an example from a text input just to kind of give people a sense of how React deals with those kind of things. But yeah, today for some reason, I guess I talked a lot more than I normally do. So sorry, everybody.
Okay. Yeah, thanks for the answer.
Sure.
Hey Quinn, I also had a question. In regards to state management, when would you use React's context API over Redux or vice versa?
It's kind of a personal choice. Context is something that the idea being that I have this value that lives way up here and I want to pass it way down to an indeterminate number of nested objects. So you usually won't use that to manage. Well, Redux sort of does use that. I think Redux actually does use context to, well, no, now you use hooks, never mind. But I think the way it used to work, use the connect thing, never used high order components. That's a different way you can do this. There's a lot of ways, basically. We use Redux most of the time because we're really used to it and we have a lot of patterns around it. And it's great for managing a lot of complicated state. It's great because you can, on a phone, you can persist it pretty easily if you use certain packages. So that's handy. You can just save the whole state of the app and then just restart it from there. But it's a lot of code. It's a lot of boilerplate you have to write. It's complicated. So if you're doing something really simple, I definitely wouldn't use Redux. But if you're doing, it's like a tipping point. There's just this point at which it stops being more work and starts being less work because your app is big enough that you want all your state in one clearly managed place.
Awesome, thank you.
Sure. But it is a great thing to learn. It's you will see it a lot in the wild. It's very widely used. And at least a lot of the ideas behind it are useful even outside of Redux, especially the whole concept of using pure functions where you kind of like set state, like you pass in the change you want to make, you get something new back. Like trying to avoid letting you mutate stuff, which is a very JavaScript problem where it's really easy to change data when you don't want to. That's a fun feature of JavaScript. Cool.
Quinn, did you you said you started as a native developer?
Mm-hmm.
Did you
Yeah.
do that at the same company you're currently using React Native in?
Yep, when I started at TableXI, it was just after Swift was new. Swift was like a brand new thing on iOS. So we learned that first, and we didn't do a lot of Android work. I actually got hired to do an Android project that kind of evaporated after a week. So, but they were like, well, we got some other stuff for you to do, so here you go. So we did like a little bit of native Android, but much more native iOS. And we kind of dipped our toes in React Native early on. We had one project where a client wanted an Android version of an existing iOS app. And we're like, well, why don't we do it in React Native? And if it works, we can make this the iOS app too. It becomes a cross-platform thing. And it was we had a good relationship with the client, and they were willing to let us experiment a bit. So that turned out okay. We didn't really know how to work with it yet. So we did things in a very simple, kind of clunky way. And then a couple of years later, it just kind of came into its own. It seemed to happen very suddenly, but it went from the very unknown quantity, like a risky thing. We didn't know if we wanted to put all our eggs in that basket, to like, oh, this is like working really well. It's established. It's got a ton of third-party support. It's performant. You don't really notice the difference between it and a native app anymore. And then, yeah, we kind of went all in, and now all of our apps are React Native, unless we have some really specific reason to do pure native. We'll just default to React Native at this point, because that's like our whole toolkit.
So where you work at, it's not like you work at a company, you work on your company's app. It's like,
oh yeah, we're consultants, so we build stuff for other people. We don't have any of our own products currently, although that might change. Who knows?
Okay, I was gonna ask, how long does it take to take an app that you have like in Swift, and take it all the way to React Native? Like, what would be like an estimate?
Depends on the app. Like that could vary wildly. Yeah, generally, we've not had to do that. Well, I guess that example I gave was sort of that we were rebuilding it in Swift, in React Native from a Swift app, actually from an Objective-C app, because it was older. So, I mean, you are essentially rebuilding it. That's the thing. You, depending on how much of the modern stuff you're using in Swift, they now have a way of writing your UI as code rather than using storyboards, which is how you used to do it. So it was like, it used to be this like physical, like a graphic interface you used to lay out all your views. And that was very hard to translate directly. But I would treat it as like you're making the app again, just maybe with some of the lessons you learned from the first time you made it.
Thank you.
Cool. Yeah, no problem. All right, so why don't I go ahead and I'm gonna share my whole screen. And I was looking at the hooks documentation somebody posted. I'll go ahead and show you how I did this. Hopefully I have time to answer any questions that might have come up if people had some trouble with this. But essentially, I'm gonna just get rid of my use effects here. Go ahead and do a single use state hook here, and I'll just call this, counter value. Set counter value. It'll start out as 0, just the way this dummy thing did. And then I'll pass that in as my anything, which I really should have named something more helpful, but we have used it for a lot of different things, so I guess it works. And I'll just make clear this is how many times the button was clicked. And then get rid of this other stuff for clarity. All right, so probably first, to make sure this was all working, I would just go ahead and I would set the value a single time. So I know that was kind of quick, but I just want to try to get through this so we have time for questions. Once again, I'm doing the use state hook. I've got a single counter value that I set at a default of 0. I've got my set counter value function, which is now passed into that on button clicked handler. You can do this outside of the header if you want, but I'm just keeping the structure we already had. So now when I click the button, it's going to set that counter value to 1. Let's make sure that works. It's already set to 0 times. That's good. So it's passing the value correctly. Click it once, it works. Now it only does it once. So what I want to do is have that go up every single time. So I'm just going to take counter value plus 1. And now it goes up just like that. So not a ton more logic, but a little bit more applicable to something you'd probably do. Usually, your views are going to respond multiple times to things and not just a single use button. That'd be kind of unusual. Hopefully that made sense to people. So did anyone run into any issues or have any particular problems while they were doing that exercise? Any questions that arose while you were doing it?
I had a question on this versus the previous one. Why would you have used a use effect in the last one when you really didn't need to, right?
I was doing use effect because I had previously showed you, I was trying to show a distinction between like, here's some value we set in the code and here's a value we set due to a user interaction. I was trying to reproduce that little flow that I came up with in the class syntax, where we had the component did mount and that changed the value. So you knew like, okay, there was initial value, it got changed in the code automatically, then it got changed again based on a user input. So the use effect was like the way to kind of reproduce that particular life cycle. In this case, yeah, since I only care that that the value changes, I don't need any extra logic to fire when it changes. You can skip use effect entirely. Basically, use effect is for side effects, as we call it, like, something beyond just like a value changed and the UI changed, like some other logic needs to fire, probably something asynchronous. A good example for that would be, I need to make an API call, right? Like the user just said, I'm going to log out. So I need to call the API with a log out. But that's asynchronous, right? I need to wait for a response from the API to say I successfully logged out before I decide I have. So in that case, I need to put that logic somewhere where I can just run as JavaScript, but it needs to respond to things that happen in the markup. And that's kind of what use effect is for, if that makes any sense. No, I saw someone shaking their head. Yeah, I wish we had time to do some API stuff because that's huge. Like calling APIs is what you're doing a lot in React most of the time. You're probably talking to a backend, maybe you're talking to a third-party service of some kind, and all that stuff takes time. So, React is designed around this really great, quick, instant gratification flow of like, hey, the data changed, now the UI changed, and it's super simple and easy, right? But in the real world, you often have to make a request and then wait for that to come back, and it might come back with an error. You don't know exactly what it is. That's where a lot of your logic is going to live in dealing with that kind of stuff. And that's partly what use effect blocks are for, since they run after it renders, but they're still deeply connected to all the variables and everything you've set up inside your component. They're meant to bridge that gap in the easiest way possible, but it's kind of hard to explain without showing an in-depth example. So just know that you'll be dealing with that eventually.
Is it a bad practice to pretty much have something in our app component other than components? Like we should keep logic within components and only use app to render components?
Yeah, for a long time, you weren't really supposed to put function, because yeah, you can put anything you want here, right? I can put another function right inside app, do a thing, and no one can stop me. And that used to be kind of an anti-pattern to put stuff inside the render method of a class component, because every time you render the component, you're also like re-declaring this function. I don't think that actually is a significant performance hit that you're ever going to see, but it just doesn't seem like the right thing to do. I guess that's what the word anti-pattern means. It's like, well, it's probably not actually going to cause you any problems. Just like, you just kind of shouldn't be doing it. Like, it doesn't feel right. However, since with the advent of hooks and everything, and the increasingly like putting logic right into the what is essentially a render method, like I don't think it's much of a taboo as it used to be. But you can always pull stuff out too, right? Like, I can put that do a thing right here outside of my app and just call it from out of there, and then it only ever gets declared once. So that's one way to do it. But it generally, yeah, like I at least, you want to think about what's going to make your code the most readable. That's sometimes a lot more of a concern than whether it's actually performance, because usually your bottlenecks aren't going to be in your React code. It's probably going to be, well, maybe you're displaying like a ton of stuff or something, but like usually it's like API calls and stuff like that are where things slow down. But it all depends on what you're doing, of course. So you kind of have to you do want to try to make decisions that make things as readable as possible and reusable as possible and maintainable as possible, in addition to whether it like runs well. All right, we got about 5 minutes left. Anyone have any other questions, or we can duck out a little early?
What would be like a good milestone or like a good way for us to gauge if like we're ready to apply for like a React job? Like when you guys hire, what's like a thing, like if you could say like, oh yeah, you know, build a counter app. But
yeah, it's a good question. I mean, it depends on what sort of level you're applying for.
entry level.
Right. So yeah, that's what we call like either an associate or we also do apprentice programs for people who we like, don't think are quite at an associate level, but could get there with a little bit of coaching. I would probably expect, you know, I would expect something. I think the real ideal thing is just show that you're willing to experiment and play around and try things a lot. Don't worry too much about getting it exactly right. I'd be much more impressed if somebody sent me a resume with their GitHub link and I look on there and it's like, oh, look at all this stuff they built. Like if they build a whole bunch of really well documented apps that do something start to finish in some useful way, especially all the like boring stuff that isn't particularly exciting, that would be really impressive to me in a way that like, you know, some brilliant bit of logic that just lives on its own, you know, as one single file would ever do. Especially because, you know, if we have a lot of applicants, we don't have a lot of time to look really in depth at their code. Like that'll come later when we do pairing exercises, when we have like particular things. But as far as like an initial impression, honestly, just if you could just do really good documentation, if you could, and write tests, like that would put you head and shoulders over a lot of people, because it just shows that like you care about communicating what you're doing to me in a clear way. That is much more important to me than like, you know, every little, you know, trick with hooks or whatever, because that stuff can be, you know, taught and learned pretty easily, but it's sometimes harder for people to just like make it very clear what they're doing, and be that, because that's such a valuable asset on any team, or even if you're working independently, just that level of communication. So that would be my advice.
Thank you.
Sure. All right, well, I think we're about at our time then. I want to make sure to give everybody lunchtime, but yeah, I hope this was a decent introduction to React. And like I said, I'll send out that GitHub link, and if you have any other questions, feel free to email me. You know, I am on the Platoon Slack. I'm not sure if I'm currently logged in, but I think I'll get pinged if somebody says anything to me, so you can reach me there as well. Yeah, thanks again for having me. It's always great to teach a code platoon for a little bit.
Yeah, thank you very much.
Thank you.
Thank you.
Thank you very much.
Thank you.
Thanks.
Have a good one.
Thanks so much.
All right, so we'll